Welcome to Stay Curious, everybody. I'm your host, Mark Marquette. It's my pleasure to bring you space news, views, interviews, and recent space history on our podcast that we're celebrating over 1,400 episodes. We being my partner, Marty Winkle. Uh, and Marty, did you see it last night? Did you see it? And I'm talking about this gorgeous aurora that your green screen you chose is over Winnipeg, Canada. Did you see it, Marty?
No, I
Well,
did not
I'm
see
not
it.
surprised, but if it was in the morning sky, which sometimes there's aurora in the morning, he's an early riser. I'm not. I did not see it from Florida, but the aurora is what we're going to talk about today. Big news where the sun uh, particles streaming 93 million miles and 3 days later hit the Earth with a horrendous geomagnetic storm. We're going to talk about that in a second, what that's all about. And it scrubbed the launch of the New Glenn rocket today, scheduled for 2:50 p.m. because of the geomagnetic storm going on. And why did they scrub it? What was the problem that could have happened? Well, stay curious about that, folks, and we'll tell you all about that. So, let me get some fun that we've had. One, we're going to have a star party Saturday at Spaceview Park. City of Titusville and ourselves are going to have a birthday party also, it looks like, up there. No, it's just a star party, Marty. We got the happy birthday logo up there. Pardon me? Okay, there's turned off. All right, join us for Star Party at Titusville with the city. We're doing an outreach with the Brevard Astronomical Society. So we have a lot of fun, 5 to 8 p.m. We'll have a steam table set up there also. And last night, it was always fun to go to the Italian American Club in Ugalli district of Melbourne, right off Route 1, right past the Aurora and Ugalli, between the Aurora and Ugalli streets there. And way in the far back is astronaut Winston Scott. Has been watching it there as Daniel DeYoung and John Tilko with me. And though my eyes were closed, I said, why not? Let's just have that on there. And I was going to show my, where'd my, oh, my, you moved the chair there, Marty, and my wrap was in there. That's fine. You don't have to get it. There's my NASA scarf on there. Um, but they had a blast, and there's Winston Scott playing the saxophone at the Italian American Club there. Yep, I am getting cold here, Marty. It's way down into the 50s there. So there you go. Winston tooting the horn there. I'm telling you, we love it when he's there. There's my scarf there for the Aurora show here. Um, Excellent. He went to the Florida State on a music scholarship, went in the Navy, and the rest is history for this spacewalker, Winston Scott, who's the lead astronaut out there at Kennedy Space Center Visitors Complex. And thank you, Winston, for all that you do, and Daniel DeYoung and John Tilko running around with their cell camera photos. Oh my God, taking pictures left and right. They were really into it, and a large crowd there. This is the second Tuesday of the month. It is the Joel's Jazz Band, Joel Space Coast Jazz Band. Joel is the conductor there. They have players from baby boomers to high school students are in this band in a rotating sort of method there. And Winston did an awesome Georgia on My Mind trumpet solo there. So if you're in town, it's the second Tuesday of the month. Look up Italian American Club. Costs you a whole $5 to go in there, and they always have some delicious food. Marty's been there several times. That's where we have our astronaut legends of NASA. We've had two different dinners there, and I've had people asking me about the dinner, Marty, that haven't been to Jay Honeycutt or Bob Seek talking. Want to know when we're going to do it again, so we'll let you know. And this was the big news last night. Thank you, Mitch Rothman. He texted me a picture, crazy sky. And I'm thinking, all right, I'm going to open this up and see a beautiful sunset. Oh, no, no, no. I saw aurora like in these panels here on spaceweather.com. That's my homepage, spaceweather.com. And you can read all kinds of things see a lot of sort of amateur photography shots of things like aurora and so forth. So what an evening it was, and what caused it was the 3 days ago a very active um, uh, a very active sunspot spewed out solar plasma into the region of the sun, and it goes out at hundreds of thousands of miles an hour, so it ejects out through the complete solar system. And I'm trying to Google up something here so I can uh, talk intelligent here in a minute. So so I got an alert from Mitch Rothman. I didn't think about going out and seeing it in Florida because we're such a far latitude. And if I had, I probably would have saw a little glow in there. So we're going to talk about what the aurora was. There's Mitch's picture there. Oh my gosh, Mitch, it was just amazing that you're watching this. He's got the curtains red of the aurora, the green along the horizon. This is Grand Junction, Colorado, West Colorado out there. And the northern lights are visible to this amazing storm, okay, that's been going on. U.S., parts of Canada, Britain saw this storm, okay. Red and green lights mostly, some purple. We're going to talk to you about what that's all about in there. And it messed up some GPS signals on there. So why does all this happen? All right. So we're going to talk about that here as we look at all of these aurora from Tucson, Arizona. Look at that. And then you got Forest City, North Carolina in the upper right. I see North Dakota on the lower right. There's Endicott, New York. All right. Oxford, Ohio. All right. And Auburn, Alabama. Wow, that's far south. Marion, Iowa. You wouldn't mind seeing that like that, okay? So this is spaceweather.com. They give you the most up-to-date news about this. And but there's another picture by Mitch. Show there. There's that's the second picture that Mitch sent me. Several. This is the second one. The Pleiades star cluster is a little miniature dipper there in the upper right-hand corner. So why do you see green? Why do you see red and pink? Well, we'll tell you all about that here in just a second. And this was from just 10 miles from us, Marty. Mims. Okay, Mims, Florida. My good friend up there, Steve Rissmiller, seeing the faint glow on the horizon up there of the aurora against a palm tree. That is a rare sight indeed. Marty, go ahead with a question or comment.
Yeah, Rocket Lady Elizabeth is asking, might it be possible to see the aurora again tonight for those of us who missed it last night? Can we see it tonight?
Yes, we are going to see it tonight. Doggone it, I forgot to print out my my stuff there, Marty. I wonder if I should go over there and get that. I am. Hang on a second here, folks, as we're going off. Marty, get on the camera there. Do you know anything about the Atlas rocket?
No. Let's
Okay.
just sing a song for everybody.
All right. Okay. This will be worth it, folks. Do a song and dance, Marty, or tell a joke.
I won't tell a joke, but I'll tell you what. We have Gary Jarrell watching, and RG Jubilee, Dave Stange, Rich Rothman, Steve Holcombs, Chris Calley, Doug Forrest, Rocket Lady Elizabeth, Dean Babcock, Tom Celentano, Carlton Bailey, and Tom Usiak.
Excellent, guys. And here I am again. Okay, there we are. I wrote up a script, and I hate ad-libbing stuff of science because I flub it up, and then everybody's saying he don't know what he's talking about. All right, so here's what I am talking about. An aurora can be aurora borealis, northern hemisphere, or aurora australis, the southern hemisphere. And I don't know if our mate Down under in Pomona, Australia, Cliff Watson, if you saw some aurora last night, let us know, bro. Well, an aurora is a natural light display caused by charged particles from the sun colliding with gases in the Earth's upper atmosphere. These particles are known as the solar wind that blows out constantly from the sun. These particles are directed at the Earth's magnetic field toward the poles, where the magnetism of the Earth brings them into the poles. And they excite in our atmospheric gases, mostly nitrogen and then 70% nitrogen and then oxygen. And they cause them to glow in vibrant colors of green, red, and blue. The specific colors and shape of the aurora depend on the type of gas, the altitude of the collision, and the strength of solar activity. Now, we've talked on Stay Curious before that we are at the peak of solar activity. For some reason, our star goes through an 11-year cycle between highs and lows of peaks, or low peaks. About 6 years, it climbs up and more sunspots are being seen. And then it peaks out with maybe 100 sunspots on the sun. And then it drops down for 6 years to zero. And we'll have zero sunspots on the sun for a couple years. I think there was over 400 days that no sunspots at all appeared during the low ebb of this solar cycle. And then it goes back up. And we have charted this for a couple hundred years. Even tree rings show you the solar cycles. Tree rings are really cool to know a lot of things about water falling as well as other atmospheric things that go on there. So, excuse me. And we'll see a couple charts here in a minute to emphasize that the sun is just a star like all the stars in the sky. It's quite a small star compared to some of them, really. And we don't know if other stars have this type of activity going on, but we assume they do. And the sun is in excited state, and it's a little bit hotter by just 10,000ths of a degree, maybe, type of thing. But that's enough to radiate through the entire solar system and heat up the Earth's atmosphere a little bit more than it's used to being when it's in a low solar cycle. Therefore, the atmosphere heats up. Heat expands everything so the atmosphere expands to a little bit higher up. And that's what brought down Skylab during a solar cycle maximum in 1976 and 77 is when the cycle was going on, and unexpectedly there was no way to elevate the Skylab without people on it, and the drag of the higher atmosphere brought it back down. So the temperature of the sun and how it affects us in this warming and cooling cycle is indeed a phenomenon that affects our Earth's atmosphere, and I think is an underrated factor in climate change. Now, man-made stuff, I'm all for it. We're polluting and creating a climate change like none other. But some of the things that are pointed out are natural causes of our Earth's environment. After all, I think 100,000 years ago, my home state of Ohio was covered with a glacier. Except from Cleveland to Cincinnati is where the glacier stopped in that diagonal, and therefore that southeastern part of Ohio is quite hilly. In the northwest, where I grew up, is flat, as they say, a pancake there. Great for farming. So we talked about the sun off and on before, but this actual solar activity caused the scrub of the rocket launch today, Marty, that we were so looking forward to. And here's Carlton Bailey's shot of the Cape Canaveral Lighthouse, and in the distance, a mile and a half away, is the Strongback and the top of the New Glenn rocket that has a probe on it that's going to Mars in 11 months and orbit Mars. It's actually a twin probe. And let me get to my smart tablet here so I can act smart, and actually my phone, and go to my next space flight here while we look at another picture of Carlton's there. That's not Carlton's, but that's a beautiful shot of the other side. You have to get on the ocean side to see where it is at. Let's see. We've got. They have not put a new date up. Ooh, okay. Um, and I've got something here that Shenzhou 20 is going to land November 14th. So we'll have to look that up for you tomorrow. I've been so busy today, didn't get a chance to. And it's not been rescheduled here. Okay, I don't see it on here anywhere. And my gosh, there's going to be so many disappointed people that were in town for the second launch of a new Glenn. We will have that Viasat uh, launch on the Atlas 5 Thursday at, it looks like 10:04 p.m., okay, tomorrow night at 10:04. And then a Starlink group Friday at 11:01, and another Starlink Friday at 11:01. What's that all? Oh, they got two launches scheduled on each pad at the same time. Well, that ain't gonna work. Never seen that before. But they don't have rescheduled the two Mars atmospheric probes, okay, going. And I just thought for fun, look at the new Glenn landed booster there, the different stages it can have compared to the Delta Heavy. All right, there's the Vulcan. See the Atlas 5? The Atlas 5 is a little bit smaller. It's going to launch. The Ariane, there's only a few of those left. There's the Soyuz above my head. All right, Falcon 9. Look how much larger the Falcon 9, Marty, is over the Soyuz. I didn't know that was such a big spread there. So, and there's the Atlas 5 compared to the Delta 4 Heavy. All right, and then there's a Saturn 5. Of course, we don't have the Starship there that would be bigger than Saturn 5, but this is a big booster. All right, this is a big deal that they land this. Look how much bigger it is than the Falcon 9, and it's got 6 legs on it to land on a barge out there. So anxious to see this work. That's why so many people are in town, like our friend Daniel DeYoung and John Tilko. So that's not put back on the books yet. So because of solar storms. So here is the sun today. Every day, the sun is observed 24/7 now. The most observed object in the sky. And why not? It's our most important object. Well, that big fat solar storm up there in the corner, and I'm going to go over here, right there, that one, is the culprit. It was over here about 3 days ago, and it ejected a lot of coronal mass into the environment, and it's spewing out at tens of thousands of miles an hour, as what we have here is a controlled nuclear bomb that's going on, okay? And astronomers number these, Marty, so that they can know what we're talking about. And this is 4224, it looks like up there, or 74 is the culprit that erupted. Now, they look a lot like Hawaiian island chains, as the electromagnetic bars, if you will, are interacting with each other. Like you see a bar magnet with iron filings around it. Think of that is going on. And there's attraction and repelling going on. And quite frankly, we don't understand enough about our own star and how stars work, to what's going on. Why is this on a cycle like it is, 11 and a half years, and pretty reliable too, over a couple hundred years is this cycle. And then we know what's on the backside coming around. In fact, when this was coming around, Marty, the sun spins at one revolution every 33 days. All right. So it's visible on our front side for about 2 weeks, about 14 days, or I mean, about 15 days, somewhere around there. 33 days, 14 days. And then on the sides, because the sun is 1 million miles across, actually 800,000 miles across and 93 million miles away, we don't see what's going on the sides, but it's actually, there because it's that close. It's three-dimensional. And so we have other spacecraft orbiting the poles and great distances from the sun to keep the backside. So we knew when this was coming around, it spewed a lot of energy. The National Oceanic and Atmospheric Administration Office usually reports these sort of things, but I thought it'd be fun to just show. We're sorry. This account will not be updated during the U.S. government shutdown, so they've not been reporting anything since October 1st. And that's why we're not seeing science in some pictures going on of like the interstellar comet from NASA photos. It's not because it's an alien spaceship. It's not. It's because NASA's shut down and there's nobody manning the telescopes or the data to show us. However, somehow this got out. Somebody is working on X for NOAA. And this is what we're looking at. This is, you see America down at the bottom. So this is looking on top of the North Pole. And you have this intense at night. See the daytime side? The aurora happens at night. That's when we see it. Okay. It also, during the daytime, can affect things because it's invisible because it's in the daylight. So this is showing you where all this coronal mass ejection is coming in and giving a geomagnetic storm level of severe, still expected through today. This is what an artist's rendition is of a geomagnetic storm ripping off the sun from a huge complex of sunspots. And what we're looking, the surface of the sun, Marty, is about 6,000 degrees Fahrenheit. But the atmosphere around the sun is 1 million degrees Fahrenheit. That's right, 1 million degrees Fahrenheit. Not 500,000, not 800,000 degrees Fahrenheit. 1 million degrees Fahrenheit is the atmosphere in the corona that you see during an eclipse. Why is that? That the surface is 6,000 and the atmosphere around it's 1 million degrees? We don't know. Tell your kids to go into astrophysics and they could solve it on there. Now, Marty, I see your question there. And of course, Marty, there's no silly questions in astronomy. So, Marty, if you've got something that you want to question, I'd certainly like to hear from you on that. Go ahead, buddy.
Yeah, I do have a question. My understanding is the sunspots are moving, right?
Yes.
Okay. So then how do we know how long it takes for the sun to rotate if there's no landmarks?
Oh, the sunspots are rotating. That's how we know.
It's not rotating at the same speed as the sun, is it?
Yes.
So
Yes.
the sunspots are in one location?
Yeah, the sunspots are right. They're in one location and they stay in that latitude, longitude, if you will, and move with the sun as this whole star is spinning. All right, but it's spinning very slowly. It's one of the slowest spinning objects in the solar system at 33 days, where Jupiter, 1/10 its size, goes around in like 10 hours, something like that. All right, spins around once. So, but great question. That no, the sunspots are fixed, so to speak, because they come up like the Hawaiian Islands. All right, it comes up from above and below the reaction, and what causes them to crackle and kick off is, well, we really don't know. But these other sunspots there that we're seeing are, I mean, all right, let's say these right here, these are the size of the Earth right here. That's maybe 8,000 miles across, the 800,000 mile globe of the sun. All right, so there you've got it. That other one's quite big, and the complex in the upper right there at 2 o'clock, that's like 5 Earths could span that. But they stay right there in that general area. Now there is some movement around, a little bit probably. That's a good question that I don't know, but no, they stay kind of in the right longitude and latitude as they go around, and then they just fizzle out, and then they may come back again. All right, and some just fizzle out. So there's something going on in this area. Also, you don't see them up by the poles. You see them in this latitude of the equator and the latitude, like on Earth, sort of between the Tropic of Cancer and the Tropic of Capricorn. That's another anomaly, is that they're strung out along a path above and below the equator. So any other questions, Marty?
No, I'm good for right now.
All right. Sure, you'll have some, but that's an artist rendition. Such violent. Now we have got a solar probe called the Parker Solar Probe that it goes out about, I don't know, 20 million miles, and then it comes back in and dips down to about 1 million miles. It's the closest anything's ever gotten to the sun, and it's the fastest man-made object because the sun's gravity whips it up to over 150,000 miles an hour, something like that. And it's taken some incredible photographs. In a way, it's more like X-ray images they look like because it's going so fast. And the heinous electromagnetic energy that's being dispelled out like in a nuclear bomb that's going on is just so intense, it's unbelievable. So there you got your solar flare, they call it, flaring off. The solar wind is constantly moving out through the solar system. You remember Buzz Aldrin put out a little aluminum foil solar wind experiment on Apollo 11. That was just to catch these particles that are coming in because there's no atmosphere on the moon. And all of this is stopped by one, our magnetic field, and two, our own atmosphere. But this magnetic shield around the Earth is very underestimated. And it's another reason why we have life here. It insulates us from a lot of stuff. Now, this solar wind coming in is not passive, it's rarefied with energy from this nuclear bomb that's going off, okay? And as you see, the aurora at the top and the aurora at the bottom is brought in magnetically by the Earth's magnetic field. We see aurora on Jupiter, we see aurora on Saturn, okay? Didn't have time to load pictures up of that. We don't see aurora around Mars. Why is that? Because Mars doesn't have a magnetic field, all right? And therefore the solar wind just buffets the surface and fries it like a microwave oven. All right. And so that's why we're not going to find life on the surface of Mars. Beneath the surface is where we'll find it. How about the colors that you saw? All right. Red is the most known color. What we have in our Earth's atmosphere is 70% nitrogen, 29% oxygen, and all the other elements. So when the intense solar activity ions come from this stream and interact in our solar system, one, there is a shear, a wind shear that's hit with a speed, and it like a neon tube illuminates the what we call the aurora. Okay, they excite in the atmosphere, are excited, which is a fancy way of saying they're crashing in and reacting with it. Now, the most common scene is green. It's emitted instead of red due to higher concentration of oxygen, and that's 150 miles up is when this is all happening. Also, the pink and reds are 150 miles up. All right. Now, the International Space Station is orbiting at 200 miles above the Earth, okay, 225, something like that, I think. So it actually looks down on aurora, and we'll see that here in a minute. Now, the rare colors to see are the purple and the blue, because that's nitrogen that's reacting at uncommon low altitudes. About 60 miles up is where it reacts with the nitrogen. Similar to red and blue, blue and purple is associated with an intense solar activity. So when you see the red and the blue, it's very intense. I made an error. The most common color is the green that you see here. This is Winnipeg, Canada in our backdrop there. So there's Gary Gerald. Hey, Gary, thanks for picking up the phone today. I called him up about something that he verified for me. I'll tell you in a minute. But his brother took this picture up in Collins, Georgia. Collins, Georgia is about Savannah. It's a little bit north of, it's in Georgia. Savannah, of course, Georgia's on the coast, but a lot of people kind of know where Savannah is. Go west and a little north of that, and you're into Collins, probably between Augusta and Savannah. It'd be a good way to put it, right, Gary? But look at that with his brother's iPhone, he said, took that up there, as did Mitch Rothman, took his with an iPhone. I'm going to tell you a little bit about how to take pictures tonight. The moon's not in the night sky, okay? It's 21-day-old moon, so that's first quarter, so it's rising after midnight. You usually don't see this intense barrage happen after midnight. You see it in the evening and morning sky. Look at that beautiful shot from Winnipeg. All right, not sure what that suspension bridge is and all, but look at those colors and reflecting into the river there. Just outstanding. Now, talking to Gary, I asked Gary, I said, has your GPS on your farm equipment been acting up? And he said, yes, it has. And farmers across the fruited plain were reporting yesterday, and that while they were doing their preparing their fields for planting, all right, that the GPS system was acting weird. In fact, some on space weather, some of them acted like it was a possessed, they said. Some farmers in Iowa, that they felt their GPS running their tractors was possessed. Now, Marty, you scratching your head going, GPS, farmers, tractors, what are you talking about, Mark? Well, Gary Gerald, look his name up. He did a great show telling us that your farm equipment is controlled by global positioning satellites, just like most of our driving is today. We all think it's cool in our modern cars that we're looking at a Google map of where we're going or where we want to go. And I did that last night going up the Italian American Club, basically to kind of give me an ETA as well as see if there's any traffic problems, because that's the best thing about the Google Maps is you see the red line where there's delays on there. So, well, Gary educated us that the rows are more concise when they plant. They're closer together. The yield is stronger. They might get, compared to what they were doing 30 years ago, they might be getting 25 to 100 more acres of land that they're using thanks to the global positioning satellites up there that also do things like record the harvest. All right. It can also analyze the nutrients in the soil, and that farmer can know by global positioning whether to put more fertilizer or less fertilizer in this path across this acreage of farmland there. So also, I haven't heard the GPS. It's really got to be intense for car GPS and stuff like that. But maybe there were some outages on the Starlink satellite system. I can't imagine that there wasn't. And we have experienced things, particularly in the 70s and 80s, where solar activity got even beyond what we experienced last night and knocked out power grids. Famously, a power grid in, I think, Montreal, Canada was knocked out. And why do I mean knocked out? The radiation and energy from the sun coming into our atmosphere shorted out electronically equipment is the best way to put it. And so the sun is such an underrated influencer in our life. And here, though we didn't have any disruption yet, we might have some tonight. And get out there and look and see if you can see any aurora tonight. And I'll bet those astronauts on the International Space Station are looking out their window and seeing some cool pictures like this, all right? Again, the most common is green. That's oxygen being excited in our lower attitudes up there, okay? Though there's more nitrogen, the aurora really has to get down lower level and smashing all those nitrogen atoms together to get them to glow like this. So think of a plasma tube, your neon tubes that have different colors to them. That color is created by the gas that they put in the neon tube, if you didn't know. Same principle here. Look at that gorgeous, gorgeous photograph from the International Space Station. So hope that you've got a little bit of 411, as they say in today's terminology, about aurora. Marty, any other questions there? As I'm not looking at my cell phone here, I'm on a roll, having a good pace here today. Well, you know, we are an American Space Museum, so how can I talk about aurora, Marty, without throwing in Aurora 7, Scott Carpenter's wonderful flight, copying John Glenn's 3 in orbit, and he wanted to be more scientific. He was an engineer also, but he was a science-minded guy. He later became an aquanaut, So he chose an aurora type for the name, and aurora of the pattern that was painted on there by C.C. Bibby. All right, there's C.C. Bibby painting aurora on there. She was an artist that John Glenn recruited. He wanted a personal something on the spaceship that was done by human hands, not just, of course, back then they didn't have what you think of like the Cricut machine that they could just put on a label like this or something like that. So there's C.C. Bibby on that. We have some of her artwork in there, and just for fun, also there is what her artwork looked like. All right, and he wanted the aurora like in the sky depicted there, though he chose red and gold for the colors. And Scott Carpenter also grew up in Boulder, Colorado, on the corner of 7th and Aurora Streets, though he says that wasn't an influence of picking this name. I can hardly believe that, Marty. He certainly knew where he grew up, and it had to cross his mind that, hey, that's even cooler that it works like that. What did this beautiful artwork by C.C. Bibby look like when it came back after 3 orbits? Yep, it was scorched on that Renee shingle there. Okay. Yep, from there to there. So how about that, folks? Turning an aurora event in the sky and around the country that I hope some of you witnessed tonight into something about that represents our American Space Museum. Look at the print, how the A at the end right there. So that's from the reentry of Aurora 7, which Glenn was in February. I think this was in May, is what my guess is going to be. And Steve Jokums or somebody could correct that for me there. So remember the colors. Red is monoatomic and diatomic oxygen and nitrogen, right? Monatomic oxygen and diatomic nitrogen. Green is the monatomic oxygen. Blue is ionized diatomic nitrogen. And purple, which is real rare, but I saw a few pictures of it, is hydrogen and helium. Distribute a bit of purple and blue. And the pink and orange come from the colors mixing. All right. And you'll see streaks, you'll see spikes, you'll see curtain waves go across. Okay. And some people claim you can hear the aurora. I've heard that the aurora has a little roar to it as these solar particles are reacting with our atmosphere and getting some velocity behind them. So one final beautiful picture from the International Space Station. Even when it's not great solar activity, you still see a good amount of aurora there. So hope that if you're local, you can come to our star party at Spaceview Park, November 15th from 5 to 8 p.m. All right. And Marty, anything else to talk about over there? As we've had our wonderful friends of Gary Gerald, RG Jubilee watching, Dave Stengy. Did Dave say if he saw any aurora up there in Michigan, or was it cloudy as usual? Mitch Rothman, you'll be out there tonight. Oh, yeah, I want to tell you just a couple hints here of how to take pictures of this. Steve Jokums, you're up north there. Hope it's clear for you to see some. Chris Callie, the same for you, brother. Go make you a painting, Chris, of the aurora. Doug Forrest, Rocket Lady Elizabeth, who brought 2 great tours here to our building last week. Dean Babcock, Tom Celentano, you certainly might see some aurora up there in Connecticut. Carlton Bailey, we'll both be looking down here in Florida, as he's not too far from here, about 20 miles. And Tommy Usiak up in Tommy Usiak's up there in Lancaster, Pennsylvania. Now, if you're using a real camera, all right, let me get Mitch Rothman here. There's Winston Scott. All right, let's just, there's Mitch's picture there. Wow. Look at the city lights there. That's a curtain effect called there with the green and the red. So this is intense when you see that much red. He was just using his cell phone camera, all right? If you're using a smartphone, put it in night mode or any long exposure that you have. Use a tripod. or set that camera on something. Like I'm setting my camera on this microphone here, okay? That's something good to do. All right, set the camera on there like that, and anchor it and try and hold it and push the button gently. But if you have a self timer of 4 seconds or 5 seconds, use the self timer button, because then because your finger mashing that button is going to move the camera slightly. You don't think it does, but it does, and can make it a little bit blurry. Use your self timer, and but if you've got a tripod and an attachment on there, if you don't have one, go to Amazon and look one up, because you'll be taking all kinds of night pictures of the Milky Way and other constellations maybe. So we could go into more detail about that, but you know the drill of how to find out things that I'm not telling you. Just Google it. If you're using, and I love it, Tom Usiak, in this thing I pulled off the internet, said if you're using a, quote, in quotes, real camera, all right, not your phone, a real camera like Tommy and I made our livings off of and paid our bills for decades. I don't even pick mine up anymore. You need a tripod, all right, because you got to hold it steady. You want a shutter speed of 10 to 20 seconds. Also on your smartphone, turn your ISO or sensitivity up to way high. If it goes to 15,000, don't go that high. Go like the next level below, like 10,000. You don't want to max all those pixels out and get little dots everywhere. So, but 2 to 3,000 ISO is normal that you want to have. But push the shutter speed up. You want to have your aperture or your lens opening open all wide open at like 2.8 or at least 5.6, not at 11 or 16. That's where your iris is tiny open. All right. 800 is usually a great ISO, or 1,000. You don't need 15,000. All right. Manual focus on a star. All right. Or push the button to see if it'll focus on a star. White balance to daylight. All right. Shoot in RAW. This is with a regular camera. All right. Not JPEG. And most importantly, use a shutter release cable or a self timer. All right. That's very important so that you eliminate the shake. I don't care how steady you think that click of the button is, you're moving the camera. All right. Note that. And get something in the foreground. All right. Tree, shadow tree, those bare trees that were in Gary Gerald's brother's picture really added to it. Get something, or get people in the foreground. Be creative. After all, you're going to look at the finished product. Do not delete anything in the field, so to speak. Wait till you get inside and can see, because sometimes even a mistake picture or something that looks blurred will have an artistic effect to it. But get your kids in the foreground. All right. Get creative with some people maybe looking through binoculars, but they're going to be looking sideways to look through binoculars, not straight at you. So they might not be looking at the object with the binoculars, but this certainly looks like I'm looking at binoculars better than this, though I might not be looking at the object. And in binoculars, you're just going to see the colors a little more emphasized there. So that's some tips of taking some pictures. Send them to me, MarQ at AmericanSpaceMuseum.org. I'll be happy to publish them on our Facebook and show them tomorrow. So I'll be out looking, and the best time is going to be around after sunset. It'll start, but it's probably 8 to midnight is when it'll peak again. So now you know something to keep alerted about in the sky besides satellites and past an International Space Station. It is aurora alerts. And one of the websites you can go to, spaceweather.com, has an alert that they'll text you that, hey, there's a big storm going on right now. Go outside. But Dave Stange, sorry, we know it's going to be cloudy in Michigan. That state up north is always cloudy. So is my home state of Ohio. That Lake Erie shield just is like a curtain, Marty, that pulls off all winter long and hides the stars from us. So you have something else, my friend?
No, Mark, you just answered it.
Okay.
RG Jubilee was asking, what's the best time to see the aurora?
Great question, our Rosalie. Yeah, before you go to bed, go outside, and what's important is get away from a street light. We all got them. So walk on the side of your home or building where you're in the shadow. Look up to the north. Okay, you're going to be looking up towards where the poles are. Look up. It's not going to be coming from the south unless you're Cliff Watson down south of the equator. So you're going to be looking north. Though I saw some pretty good in the east there with that Mitch took with the Pleiades in it. That's almost directly east. So could be fine. It could be a bust. But I guarantee you there'll be some little activity for all you northerners north of the Mason-Dixon line, so to speak, which is the Carolinas and across to Colorado. You're going to see something. So down here, maybe not so intense that we see it all the way down here, but I'm going to be looking. So hope you are too, and let me know what you see. So thank you all for watching. Man, sorry about the disappointment for all of you seeing that new Glen get lifted off. So the crew at Blue Origin's probably fit to be tied also, but not. It was and I didn't say why. What could happen is it wasn't the launch or going through the aurora. It is the storm that is flowing through the solar system is so intense that they're afraid it could wipe out some of the electric circuitry on these Mars probes that are atmospheric investigation pair on there. That's why they didn't launch it. They're afraid that the intense storm that's going on in the solar system, meaning between here and the moon, will be so intense that it would short circuit some of the electronics on it, is an easy way to say that. Yes, Marty?
Did the astronauts on the space station notice any differences?
Yes, they might. These do provide more. Excellent question. They may have gone into a safe area in the Quest module. I think is a thicker walls in there so that they're not exposed to more radiation. Okay, from these storms, there is an amount of radiation to them that's more intense. And this is why we think the atmosphere of the sun is heated to 1,000,000 degrees and the surface is only 6,000, is this reaction is so exciting of these molecules ripping off the sun in a flare and interacting that creates a lot of heat, like rubbing your hands together. This is what's going on in the atmosphere, is the soul is radiating and heating up in there. So but that's another thing we can look into. Did the space station occupants and the Tiangong Chinese occupants go to a safe haven during the peak of this? They certainly keep up with it, Marty. So thank you for asking that. Anything else? All right. Well, we're going to have a fun time tonight, having a little docent gathering. Our docents are getting together for a little recognition reception, and we're going to show the Jay Honeycutt 28-minute documentary to them and have a good time, and we'll report on about that to you tomorrow. So thank you all for watching. I appreciate everybody interest in Stay Curious, no matter what the topic. We're very strong with a great following of wonderful space lovers like you all wanting to know more. So tell your friends, get outside tomorrow night or tonight and let your eyes dark adjust a little bit, shield yourself from that street light, and you might see something very unworldly in the skies tonight. So until next time, that be tomorrow, I'm Mark Marquette saying we can't wait to see you in our museum to bridge the space between us.